start recording. There we go. All right, before we start recording, I just want to write down a couple of things so nobody can say, I didn't know. And I've been talking about this for a while now, but I just want to go over, and I've ran out of black pens, so we're going to have to use dark pens like blue and brown. Anyway, I want to make sure everybody understands that I'm going to talk about 9.1 and 9.2, and that's going to be it, Tuesday and Thursday. And your last test is Unit 4, and it will be on 9.1 and 9.2. So we're only talking about 10 questions, math questions, along with the bonus questions. If I put them on there, I can't remember if I put them on there or not. And the final exam will cover all the tests, Unit 1, 2, 3, and 4. Okay? The dates are on My Labs Math. You get 2 on the final exam. You get 2 attempts. Take the higher of the 2. You have 2 hours, even though the tests don't take 2 hours. Chances are it's around 33, or I think it's 33 questions. I'm not sure. And let's see, what else is there? You have until whatever My Labs Plus says on the date. My Labs Math, sorry. Okay? And the same with the last test, except it has 3 attempts. You have 90 minutes to take the test, and however many questions, probably 10 math questions out of 9.1, 9.2, and the date is on there also. The reason I'm telling you the date is on there is I don't want to give away some of the charity that I'm giving. You know, if you don't know what I'm talking about, then you're lost. All right. Here is what I want you to write down. I want you to write 4 columns. I'm going to try to make this. Can I make this fit the whole screen? I guess I can't. Try this. I don't know if that's going to, no, that's, well, we'll try that. Makes it a little bit bigger for y'all. All right, I want everybody to put this, I want you to transfer it to a big index card, okay? Some of you can put it in a spreadsheet. If you want to put it in a spreadsheet, that's fine. This is kind of a cheat sheet, so you don't have to do it on the calculator every single problem. Y'all remember these? Y'all remember these? Okay, well, this is kind of like this. Instead of having to draw this 15,000 times, you have this. Instead of having to do 15 extra calculations with your calculator, you have this index card. So go ahead and copy down the index card. The first column is called confidence level, and that will be given. That's why I got it highlighted in yellow. Yellow means that it will be given, and it goes down to 99. I'm going to make it smaller here in just a second. The second column is called alpha. Alpha is what is called the complement of the confidence level. So if you've got a 95% confidence level, which is 0.95, your alpha will be the complement of 0.95, which is what? 0.05. Then you're going to take alpha and divide it by 2. That's these numbers right here. And then you're going to do inverse norm left of this area. And that'll give you, and we're taking the absolute value, so we're not using the negatives. All right, so I want everybody to write that down. I'm going to show you how to use it once we get finished with doing the index card.
Gmail.
Okay, in a second, I'm going to move it up where you can see 97, 98, 99. And this last is highlighted green because that's your z-score that you need for calculations. And that's why I highlighted it green. The stuff in the middle that doesn't have a highlight, that's just how you get to the z-score. Another term for this green highlighted area is z sub alpha over 2. So the book may have alpha right beside that z right there. Miss Polar, is Mr. Polar graduated yet?
No, sir, he hasn't yet.
He's such a loser.
He is.
If he get off the bottle, he'd graduate a whole lot sooner. He surprised me switching over to HVAC though. He surprised me. Because he had done taking all them calculus classes and then switch over to HVAC. I was like, daggone. He must have stepped into a gold mine or something. Is he still doing the HVAC? Huh?
Yes, sir. He still is. He likes it.
Well, that's good. Tell him after he graduates, I can hire him to come service my HVAC system.
Okay.
He goes that route.
I'll
A lot
tell
of
him
people do that. They end up working for a company, and then they end up doing that on the side, and they make a lot of money.
Yes, sir.
At like $150 just for a site visit. Yeah, make a lot of money. Okay, I'm gonna move this up. And there's the last. I messed up on that. That's 2.58 right there on the bottom. 2.58. Now I promise you, if you put this on a big index card, or you can put it on a small one, if you got 10 lines, You're going to have at least 10 lines. If you can get this on an index card, it'll keep you from having to do extra calculations with your calculator. Now, let me go ahead and tell you right now, the reason I put 90 to 99, does anybody wonder why I didn't put 100? What would 100% confidence level, what would that mean? If you're 100% confident in your work, that means it's what? Are y'all like going to talk or say, I don't know, or, you know? What would 100% confident mean? That your work is
perfect.
Blank. What?
Perfect.
Perfect. And what's wrong with that word?
Nothing's perfect.
Nothing's perfect. So that's why I did not include 100. Why didn't I go down to 70? That means my work, I got a 70% confidence level that my work is good. What does that mean in real life? I got a 70% confidence level. I'm lazy and I'm suck. That's what that means. Okay? You would not walk into a board of directors meeting or a department head meeting saying, you know, I'm about 70% confident that this work is good. Okay? So why did I include 90 to 99? Because I want my students, you know, I don't know if you're going to be doing this stuff in the future. You may, but I don't want you putting my name on your knowledge of and go in there with a 70% confidence level. That's like going in there saying, you know what? I got a hangover. I didn't do the work, but I just slapped some stuff together before this meeting, and I'm 70% confident. Okay, that's why I didn't include 70%. But what if I did, like in a homework problem, because they regenerate the numbers, what if they gave you a 70% confidence level? Well, this is what you do. I hope, did everybody get that? Has everybody got those? I mean, you should have plenty of time. I mean, anybody? Of course, I only got 3 people that will talk to me, so. Get so old. It's all right. One day, you're going to be paid back. You're going to have somebody that works for you or works with you that doesn't communicate. You're going to get paid back. All right. What if you're given a 70% confidence level? Given a 70% confidence level. Okay, so therefore, the confidence level is equal to 0.7. Therefore, alpha is equal to what? 3. And what's half of 30 cents? $0.15, Hubert. Now, why did I write 15 cents with 4 decimal points? Because I want you to trigger that is an area. So you need to type in inverse norm 1500 left, 0.1500 left, and give me a z-score, someone. Second bars, inverse norm, 0.1500. Somebody give it to me. Left. I don't need the negative. I don't need the positive. Just give me the number.
It's negative 1.04.
So your z-score is 1.04. We take the absolute value. All right, let's try 85%. Confidence level equals 0.85. Wait a minute. Given a 85% confidence level, the confidence level is equal to 0.85. Therefore, alpha is equal to point what? 0.15, Hubert. That's right, class. Alpha over 2. What's half of 15 cents? 0.0750. 7.5 cents. And somebody give me inverse norm for 0.0750.
Negative 1.44. 1.44.
1.44 or 1.45?
It says
Round.
1.44 for me. It's 439.
Okay. All right, let's do one more, because these are test questions that I'm going over right now. So I'm going to give you 3 of them. Given a, let's see, I've done 70, let's do one like 82. No, let's do 72. Given a 72% confidence level, which really sucks, my CL is going to be equal to 0.72. Therefore, alpha is equal to point what? 28. And alpha over 2 was half of 28 cents.
14.
And somebody do an inverse norm left of 0.1400.
1.08.
Okay, now there, technically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There is 13 test questions right there, because they're going to ask you, the question will say, you know, for a 70% confidence level, find Z. Or Z sub alpha over 2 for 70% confidence level, or something like that. Okay, so that's how you find Z.
Hubert,
Yes.
I have a question.
All right, communication, yes.
I think you already went over it, but I think I missed it. How did you get alpha?
Alpha is the complement. Alpha is the complement of 0.9, of 0.91, of 0.92, of 0.93. So you got to change the percent into a decimal. Change the percent into a decimal, and then you can get alpha. Technically, you could get alpha with a percent, but you can't calculate a percent. You have to change the percent into a decimal. So is the complement of 0.9, 0.1. Complement of 0.91 is 0.09. Because what does probability go to? 0 to what? Somebody? Measurement of probability goes from 0 to what? What's the area under a curve?
1.
1. Probability goes from 0 to 1. So under the curve, the probability is 1. So if I go 0.9, what's the complement of 0.9? 0.1. What's the complement of 0.91? 0.09, and so on. Does that answer your question?
Yeah.
Thank you. Thank you, Ms. Yarborough, for asking a question when you needed it. Thank you. That's called communication. Some of y'all need to take note of that. All right. No, I'd just rather sit here and quiet and not ask questions. Okay. Now let's talk about what you're going to be doing in 9.1. You're going to be finding p hat. That's called p hat, or p. Don't ask. Just you could say p if you want to. P is equal to x over n. And what have I told y'all since the beginning of the semester about n? N is always what?
The biggest number.
Thank you. Write that down, because evidently y'all don't remember. N is always your biggest number, so therefore always the denominator. Now, remember what I told y'all in chapter 7, that area is equal to probability, is equal to percentage, is equal to decimal. Do you remember me telling y'all that? Well, that's also equal to a fraction. Can I change a fraction into a decimal? Yes. Can I change a decimal into a percent? Yes. Decimal probability? Area? Yes. Under a curve, remember? Chapter 7. So I can question can say, let's do an example of a question. 500 employees, 275 are sick. I caught the flu. I'm sorry, there is no more flu. Whatever, COVID. Yeah, there we go. If you have a wreck and you have COVID and you die in that wreck, you die of COVID. All right? So what is p hat in this case? 275 over what? Hubert. Thank you, Clay. Appreciate it. And somebody give me that number. What's 275 over 500? Just give me 2 decimal points. Point what?
5.5.
Okay. So in this question, I was given 2 numbers, and you would calculate p hat. Everybody with me? And this is question example number 1. All right,
Hubert?
question example number 2. Yes. Somebody said my name.
I'm not sure if it's just mine, but you're lagging really bad and it's kind of hard for me to understand you.
Oh gosh, don't tell me that. Is my drawing lagging?
Yes, sir. It's doing it for me too.
Well, I don't know why, because I just rebooted the system. I don't know why it's doing that. I'm sorry is all I can say. There's nothing I can do about it. Hold on a second. Let me turn down the resolution. Maybe that's it. Let me turn it down to 640. Maybe that'll help. Let's see what happens now. Okay, example number 2. The same company, a company, any better? A company reports, any better? Is that better with the lagging?
Yes, sir.
It is? Wow. A company reports, that's something I need to do from now on. I need to drop it down. A company reports that 55% of employees are sick. Okay, here, this question does not give us a fraction, doesn't give us numbers. It gives us what? A percent. So we say P hat is equal to 0.55. Everybody with me? So what I'm trying to tell you is P hat can be given as numbers, just like here, and you plug it in to X over N. It can be given as a percent. It can be given as a decimal. It can be given as a fraction. I want everybody to understand that. So the first formula that you need to know for chapter 9 is this formula. And you need to realize that it also can be given to you in a question like this. I can't believe that changing that resolution helped the lag, which makes sense, but I just didn't think about it. Okay, now, if you can get P hat, then you can get Q hat. Now, in chapter 6, what was P and Q? What was Q to P? If P was equal to 0.25, sorry, that sucked. If P is equal to 0.25, therefore Q was equal to what?
0.75.
So somebody tell me what Q is to P.
The complement.
Complement. What makes up the whole? So P hat, if P hat is equal to 0.25, what is Q hat equal to? 0.75. Now, what is the difference between P hat and P? Well, there's really not any difference. But in chapter 10, when you do get into hypothesis testing, P hat is what we call the critical point. Okay? And it's kind of like changing a fraction to a decimal. The difference between P and P hat is like the difference between a fraction and a decimal. It's really the context. If it's called P hat, you know it's a critical value, and you need to know it for hypothesis testing. Versus P, here, you know this is used in mu is equal to NP, and the standard deviation is equal to NPQ. Okay, so if they give you P, it's not a big deal versus P hat. They're just getting you ready for hypothesis testing. Okay, so if P hat is equal to 0.99, what is Q hat? I need somebody besides Mr. King to say the answer. What is Q hat? Complement. Both of them have to equal what? 1. So if P hat is 0.99, What's Q hat?
0.01.
Thank you. If P hat is equal to 0.65, what is Q hat?
.35.
Thank you. All right, so right now, what should you know? You should have an index card. You should have that cheat sheet. You should know that P hat is equal to X over N, or it could be given to you as a percent, a decimal, or a fraction, or numbers like here. And you need to know that Q hat is the complement of P hat. So make sure you make a note that Q hat is the complement of P hat. Now, with the confidence level given a confidence level, the question will ask for a confidence interval. CI. Confidence interval is P hat, and we're going to add the margin of error on the right, and we're going to subtract the margin of error on the left. And that is a confidence level. Do y'all remember in the first, or chapter 3, where I told you how to add the standard deviation on the right and subtract the standard deviation on the left? You remember me telling you how to do that? Well, you're going to do the same thing now, except it's going to be, and you're going to have these. And you're going to add the margin of error on the right, and you're going to subtract the margin of error on the left. And the margin of error is equal to, there's your z-score, z sub alpha over 2, times the square root of P hat Q hat over N. And yes, that's another couple of highlights. Okay, so I'm going to go back to the beginning. You need to have your cheat sheet. You need to know that P is equal to X over N. You need to know that Q hat is the complement of P hat. And you need to know that the margin of error is added to the right and what on the left? Subtracted on the left. And the margin of error is equal to the z-score. That's that last column on your index card, times P hat Q hat over N raised to the 0.5 power. And that'll take you most of the way through 9.1. So let's look at 9.1. Let's look at some questions. Where's my questions? There we go. And homework. And this is 9.1, right? And let's see if they start off with a couple of easy ones. A blank blank is a value of a statistic that estimates the value of a parameter. Let's say a confidence level. Confidence level. This is one of those Philadelphia lawyer questions. Nope. Let me look at the choices again. Oh, a point estimate. A point estimate is the value of a statistic that estimates the value of a parameter. Sorry about that. I didn't see point estimate. All right, here we go. Compute the critical value z sub alpha over 2 that corresponds to 81% confidence level. This is a test question. So go back to I'm going back to right here. These notes right here. We did an 85, a 70, and a 72. So I want you to do an 81% confidence level. This is a test question. Now you've got like 9 of these to look at. I got the flu. Okay, so I'm going to add that to this one. I got a little room down here. So I'm going to add that to this one. Given an 81% confidence level, the confidence level is equal to 0.81. Now, the reason we change it to a decimal is because percentages you can't really calculate. You can't put 81% into a calculator. If you do, the calculator is just going to turn it into a decimal. You can't calculate a percent. You can calculate a decimal. Therefore, somebody tell me what alpha is.
.19.
Thank
Oh.
you. Therefore, alpha over 2, what is 0.19 over 2? Well, that would be let's see, half of 18 would be 9. So that would be 0.950.
Yes, that's what I got.
And I put it in 4 digits, so that would trigger you going, oh, that's an area, so I need to use inverse norm. And somebody give me the z-score for 81% confidence level.
It's 1.31.
Okay, so now you got the index card, that's 10 questions. And now you got 4 questions on these notes right here. I'm trying to tell you that you don't have any excuse to miss this question. So 1.31, and you feel good about yourself. So the first question sucked. It was a Philadelphia lawyer question, and I don't put those on the test. I tried not to. The second one, that is a test question. Next. All right, you do 90. Well, you don't have to do 96. Why? Why do you not have to calculate 96?
Our index cards.
Thank you. Miss Yarborough, you know you're not supposed to talk to me. You know these other people are they're gonna fuss at you, but I appreciate it. Okay, so somebody give me 96% confidence level. What's the Z-score? Well, for those of you that don't have it down, there is our handy dandy sheet, and 96%, 2.05. Oh my gosh, Hubert, you mean those are test questions? Yes. Will people miss them? Yes. Some people could break an anvil with a banana. All right, now look at this one. Determine the p-hat if the margin of error is given below. Okay. All right, look at there. Lower bound is point. Remember, our margin of error, I'm going to go back here. I'm going to show you that your notes will help you if you use them. Our margin of error is right here. So I subtract, for the lower bound, I subtract the margin of error from p hat. From the upper bound, I add the margin of error to p hat. Everybody with me? So what does that mean? If I need to find p hat, that's just like the mid-range. Somebody tell me what the formula for the mid-range is. Chapter 3, what is the formula for the mid-range? What is the formula for the mid-range? Highest plus the what? Oh my God, really? Are y'all telling me that y'all regurgitate that information that fast? I mean, you just lose it that fast? What's the formula for the mid-range? Highest plus lowest divided by what? 2. Y'all suck.
For some reason, I was thinking that was it interquartile thing?
You were thinking of the interquartile range. Yeah, that's different.
Yeah, I couldn't remember that formula. That's what I
But
was.
at least you could remember the word. That's good. At least you could tell me what confused you instead of crickets. You know, I like to have students either say, I don't know, or I was thinking of this, or blurt out the answer. But no, in the millennial Tide Pod generation, you just sit there and you just don't say a word. Maybe one day y'all will figure it out. So in this problem, what do they give you? A lower bound and an upper bound. Well, that's the high plus the low. So here, we're going to take 0.493 plus 0.827 and divide by 2. And that's going to be equal to your p hat. So I'm not going to ask y'all because y'all won't tell me. So except for 3 or 4 people. And I do appreciate y'all that have taught this morning. Thank you very much. There's still 60% of the class that just sits there. Okay, 0.493 plus 0.827 equals divided by 2. I got 0.66. Y'all check me, please. Yes, no, maybe.
That's
That's
what
what
I
I
got.
got.
Okay. Therefore, and I'm just writing this down so you'll know. Therefore, Q hat is equal to what? Well, just -1, people. 0.34.
34. Oh.
Now, you don't need that P hat. I just wanted to kind of jog your memory because you need to be you should have been in that habit a long time ago, but anyway, there is our answer to our question unless they want something else. So the point estimate is 0.66. The margin of error. Oh, we got to use our formula that Hubert gave us and highlighted so we would not forget it. So write that down and we'll go back to it. Go back to the question. Margin of error is equal to the z-score of alpha over 2 multiplied by p hat q hat over n, and raise that p hat q hat over n to the 0.5 power, or take the square root. So margin of error is equal to z sub alpha over 2 multiplied by, I'm going to put p hat times q hat over n. I'm going to put a 0.5 up here because that's the way I do my square root. So let's see what they give us in the question again, because you got to read these questions. Determine the point estimate of population proportion to the margin of error for the following confidence interval. I don't see the confidence interval. I don't see the confidence level. And the number of individuals in the sample with the specified characteristic. Lower bound, upper bound, and n is equal to 1,000. Now, the only problem I got is they haven't given you a confidence level. They might use 90% because in some questions it's assumed to be 90%, but let's go ahead and fill in what we know. Margin of error, I didn't think I saw margin of error is equal to z sub alpha over 2 0.66 0.34 over 1,000. Didn't it say 1,000? I'm going to check something right quick because I do remember seeing somewhere in one of these books, 103 or that they assume a 90% confidence level. Hold on. Oh, they did it a different way. Okay. I still don't understand how they got. Oh, okay. They're just calculating it using subtraction. Okay. Okay, forget about this. I got the cart before the horse. This is later. Okay. All right. The margin of error is between 0.66. This is P. This is in the middle. So you got 0.66 in the middle, and you've got 0.827, and then you got down here 0.493. The margin of error is right in here. Because what do you do on the right side? What do you add to 0.66 to get 0.827? You add the margin of error. What do you do on the left side? You subtract the margin of error. So does everybody agree that the margin of error is somewhere in here and we just got to find it? Because you got, I don't know why this mouse is going crazy, because you got 0.827 here, and you got 0.493 here, and you got 0.66 here. So the margin of error has to be in here because you added it over here and you subtracted it over here. Does everybody agree with that? So somebody tell me how to find the margin of error without doing this, because they don't give us Z. They didn't give us the confidence interval. So since we don't have the confidence interval, we got to go back to basic math. So somebody tell me how to get, there's two ways to get it. Somebody tell me how to get it.
Subtract 0.66 from 0.827.
Or subtract 0.493 from 0.66. Either one. So I'm going to write it down for you. Two ways. 0.827 minus 0.66. Or 0.660 minus 0.493. Should you get the same answer? Yes, Hubert, you should get the same answer. All right, somebody do it. Well, I'll just do it. That'd be a 7. That'd be a 6 and 7. I got 0.167 there. 10 minus 3 is 7. 15 minus 9 is 6. And borrowed 1 here. 5 minus 4 is 1. So the margin of error is equal to 0.167 or 16.7%. In statistics, 16.7% of margin of error really sucks. You want to keep it around 2 or 3. When you look at a poll, a national poll, you do not want to see margin of error of 17%. You want to see a margin of error of 2 or 3% or less. Knowledge is power. If you look at a poll, the 17% margin of error, is anybody got a bird in a cage? That poll, you should put at the bottom of that bird cage because that's all it's worth. Other than that, it's Kool-Aid. You see what I'm saying? Bad news, bad information, Kool-Aid. Anything above 3% margin of error is Kool-Aid. I'm sorry. Not that our media puts out Kool-Aid. Margin of error is 0.167. I'm sorry that I got ahead of the game. I just was wanting to show you how to use the formula, and I forgot about just subtracting. All right, the number of individuals in the sample with the specified characteristic. So multiply 1,000 times, let's see, the point is 0.660. Okay, so 0.660, that'd be 660. Okay. 0.660 or 660. You just multiply your p hat times 1,000. Okay, hold on just a second. Start. All right, y'all do. So you have to see if you can. Okay, now this one gives you confidence interval. So if they ask for a margin of error, you will be able to use the formula on this one. Go ahead and take a second and do that. Okay, so this one says x is equal. So what can we calculate first? That means I want somebody to say something. Ms. Poor, what kind of internet provider do you have?
Well, I use my hotspot, and we have AT&T here.
Okay, why don't you use AT&T? I'm just curious.
Oh, well, we had like Wi-Fi in our house, but because we live out in the sticks, we don't have any service.
Oh, so you don't have AT&T anymore?
No, sir, just through hotspot.
I was just wondering because your video is a little bit different. I was wanting to know for my own personal in the future, you know, when I see a video like that, why. That's why.
Sir.
It's I mean, I can see you and everything. It was just a little bit different from the other people's.
Yes, sir. It's probably because I'm about out of hotspot data, and I only have one bar here.
Okay.
Yes.
All right. So somebody tell me what we start with. What's the first formula we started with?
Is it inverse norm?
No, not that. Not the index card. What's the first formula that I highlighted?
P hat.
P hat. P hat is equal to x over n equals x is 105. N is 150. Somebody give me 2 decimal points, please. Let's see what they say. They want decimal points. 3. Give me 3 decimal points. 105 divided by 150.
It's just 0.7.
That's so hard for people to say. Therefore, Q hat is equal to what?
.3.
0.3. We got N is equal to 1,000. I'm sorry, N is equal to 150. So we've got a lot of things for our formula for margin of error. N is equal to 150. Only thing we need is Z sub alpha over 2. So somebody look on your index card and tell me what the Z-score is for 90% confidence level.
$1.64.
1.64. So now you've got everything you need to find out what the margin of error is. Yeah, that's what they're gonna ask for. So, margin of error. My Z-score times PQ over N raised to the 0.5 power. So that's going to be margin of error is equal to 1.64, 0.7 times 0.3 divided by 150 raised to the 0.5 power. I'm going to go ahead and calculate that while y'all calculate. Clear. 0.7 times 0.3 divided by 150 raised to the 0.5 power times 1.65. So my margin of error is 6% or 0.06. Margin of error is usually to the second decimal point because it's usually to a percent, which still sucks as far as statistics go. I'm going to write it out though. 0.061737 ... So we were able to find our margin of error. Now, like I said before, most of the time, the margin of error is rounded to 2 decimal points, maybe 3. So that would be 0.06 or 6%. So now you have everything you need to construct your confidence interval. What goes in the middle? 0.7. So 0.7 is in the middle. And what goes at the top? Well, we got to add 0.7 plus 0.06 is 0.71. And what's 0.7 minus, what's 70 cent minus 6 cent? 64 cent, Hubert. That's right, class. So there's our lower bound, and this is our upper bound. And now you just put a P in the middle. P hat is between 0.76 and 0.64. And this is your confidence interval. That is a test question. So I've gone over like 3 test questions. I think. Let's see. 1, 2, 3, 4. 4 test questions. I don't count the Philadelphia lawyer question. All right. So 105 and 150. What is my lower bound? My lower bound is 0.64. They want 3 decimal places. I'm sorry. Does anybody have, let's see, let's see, 0.7 minus 0.061. 0.039, 0.639 maybe. And then 706, that'd be 0.762 maybe. Oh, that's all they asked. Okay, sorry. Next. I'm almost done y'all's homework for you. In a survey of 2,075 adults, ding, 2,075. What is that? Well, it may be X, it may be N. I don't know yet. In a certain country conducted in a survey of adults in a country, conducted during a period of economic uncertainty, 61% thought that wages paid to workers in industry was too low. The margin of error was 2 percentage points. So that means 0.02 with a 90% confidence level. First of all, we got to write all this down. We got a lot of stuff to write down. And that in a survey of 2,075, that's N. So with this problem, I got to write down everything. I don't even want to know what the question's asking. Okay, N is equal to 2,075. P hat is equal to 0.61. Therefore, what is Q hat? .39. Hubert, thank you, class. Appreciate the interaction. The margin of error, 0.02 or 2 percentage points with a 90% confidence level. Good gracious, I don't know what they could ask for. Unless they want to find the, no, they got N, so I don't know what they're going to ask for. We are 95%, we are 90% confidence that 61% of the country during this period of economic wages paid to workers are too low. Okay, yeah, that interpretation, let's see. We are 90% confident. No, I wouldn't say 90, well, 90% confident that actually it should say 61. 61 minus 2 is what? 6.61 minus 0.02 is like 0.59, and 61 plus 0.02 is 63. So the lower bound is 0.59 and the upper bound is 0.63. So I'm 90% confident that it's going to fall between 0.59 and 0.63. That's the way it's supposed to talk about. I would say it's flawed because the interpretation suggests that this interval indicates that the level of confidence is there's no interval. I would say D. There's no interval. They don't give us a confidence interval. We are 88 to 92% confident. No, that's not right. They're trying to teach you what a confidence interval is in this question. That's not right. You can't use 88 to 82%. No. Like I said, it's going to be 0.59 to 0.63. So if the interpretation is flawed, you just got to see which one it is. I would say D again. It could, no, they're giving us the interval, but it's not the right one. It should be 0.59 to 0.63. So I would say D again. Nope, it must be C. Okay, B. What does it say? The interpretation indicates that the level of confidence is varying. Well, that's just 88 to 92 is just wrong. That's just wrong. We are 95%. There it is. 0.59 to 0.63. That's reasonable. Okay, I don't like that one because this one kind of confuses you. In 90% of samples of adults during economic certainty, the proportion who believed wages paid to workers in industry were too low is between 0.59 and 0.63. I think it's reasonable. I hate these Philadelphia. This is not a test question. Damned if you do, damned if you don't. C. The interpretation. Well, what happened to the question? The interpretation is flawed. The interpretation suggests that this interval sets the standards for all other. I guess you could say D is too broad of a statement. Write that down. D is too broad of a statement. Because it says 90% of samples of adults in the country. I would just say it's too broad. Let's go to another. I want to get to a question that I'm going to ask. All right, try this one, and we are finished for today. It's 9:25. Okay, you should be able to start working on 9.1 homework. Any questions? All right, y'all get out of here, and I'll see y'all Thursday to go over the rest of 9.1 and 9.2. See y'all. Have a good day. It's a beautiful day in the neighborhood.
See
See ya.